In January 1943, Admiral Karl Donitz viewed the Battle of the Atlantic not as a series of heroic naval clashes, but as a cold, brutal ledger. He measured success by a single metric: the total tonnage of Allied merchant shipping sent to the bottom of the ocean. The math was devastatingly simple. If German U-boats could sink ships faster than the United States and Britain could build them, Britain would suffocate and the Allied war machine would starve. In 1942, with roughly 8.5 million tons of Allied shipping destroyed, that terrifying equation seemed to be working perfectly for Germany. But this mathematical war was about to shift, and not just because of radar, long-range aircraft, or heavily armed convoy escorts. The Battle of the Atlantic is often remembered as a tactical duel between submarines and destroyers, a game of cat and mouse played out in the freezing darkness. It was that, but at its core, it was a ruthless economic race of industrial throughput. Germany's entire naval strategy depended on shrinking the overall pool of Allied transport vessels. A U-boat didn't need to sink battleships. It just needed to send cargo ships to the bottom faster than shipyards could replace them. If the total carrying capacity, the ships delivering troops, fuel, food, and ammunition, went down every month, Germany was winning. If it went up, the U-boat campaign was fundamentally failing. The crisis for Donitz was not just that escorts were getting better at sinking his submarines. The crisis was what was happening thousands of miles away from the Atlantic battlegrounds, in shipyards across the United States. A new, terrifying reality was taking shape on assembly lines in places like Richmond, California, and Baltimore, Maryland. The central question of the Atlantic War had changed. It was no longer just about whether a convoy could survive a wolfpack attack. The question was now mathematical. What happens to a submarine strategy designed to bleed an enemy dry when that enemy begins launching new, fully functional cargo ships faster than the U-boats can physically sink them? What happens when destruction is outpaced by mass production? To understand the sheer terror that this mathematical reality inflicted upon the Allied High Command, one must look at the ledgers closing out the year 1942. The numbers were not merely concerning, they were catastrophic. By the end of December, the accounting of the Atlantic War revealed a grim, unavoidable truth. The Allies had lost roughly 8.5 million tons of merchant shipping over the preceding 12 months. To put that figure into perspective, it was a hemorrhage of steel, cargo, and human life that outpaced the combined shipbuilding capacities of the United States and the British Empire at that time. The deficit was growing, and it was growing at a pace that threatened the total collapse of the Allied logistical network. This wasn't a slow leak, it was an arterial bleed. The devastation was largely driven by a campaign the Germans called Operation Paukenschlag, or Operation Drumbeat. When the United States entered the war in December 1941, Karl Donitz saw an unprecedented opportunity. He dispatched a wave of long-range Type 9 U-boats across the Atlantic, targeting the eastern seaboard of the United States and the Gulf of Mexico. What they found was a defender completely unprepared for modern submarine warfare. American coastal cities remained brightly lit at night, silhouetting coastal freighters against the neon glow of Miami and Atlantic City. There was no organized convoy system, no blackout regulations, and a shocking lack of coordinated anti-submarine patrols. The U-boat commanders referred to this period as the second happy time. They didn't even have to hunt. They simply waded along established shipping lanes and picked off individual, unescorted merchantmen. Tankers carrying aviation fuel from Texas, freighters loaded with raw materials, and cargo ships bound for Britain were sent to the bottom with terrifying regularity. In just the first 6 months of 1942, over 3 million tons of shipping were destroyed off the American coast and in the Caribbean alone. This slaughter off the American coast was just one theater of a much larger systemic crisis. Britain, an island nation, and the wider Allied coalition fighting in North Africa and the Soviet Union were entirely, desperately dependent on ocean supply lines. Every bullet fired by a British soldier in Egypt, every gallon of aviation fuel burned by a Spitfire over Kent, every crate of rations feeding the population of London had to cross an ocean. The Soviet Union relied heavily on the treacherous Arctic convoys for trucks, tanks, and raw materials to keep the Red Army fighting. The war effort was a massive, insatiable machine, and merchant ships were the only arteries capable of feeding it. Donitz understood this fundamental strategic reality perfectly. He did not need to sink the Royal Navy's battleships or aircraft carriers to win the war, though such victories made for excellent propaganda. His strategy was entirely focused on the merchant marine. His goal was not control of the sea. His goal was denial of passage. He calculated that if he could maintain a steady, high rate of merchant ship sinkings, a rate that exceeded the Allies' ability to build replacements, the total pool of usable shipping would inexorably shrink. It was a strategy of suffocation. The German mathematical models projected that once the global Allied shipping pool dropped below a critical threshold, the entire logistical apparatus would begin to seize up. Food rationing in Britain would become starvation. Factories would shut down for lack of raw materials. Armies could not be transported across the Channel for a European invasion, and those already deployed would run out of ammunition and fuel. The arithmetic of late 1942 suggests that this collapse was not just possible, but probable. The U-boat fleet was expanding rapidly, with German shipyards turning out new submarines at a steady pace. Despite the introduction of the convoy system on the American coast in mid-1942, which ended the easy pickings of the happy time, the U-boats simply shifted their focus back to the mid-Atlantic gap, the Black Pit. This was an area of the ocean beyond the reach of Allied land-based aircraft, where U-boat wolf packs could surface, coordinate, and attack convoys with relative impunity. Every time a merchant ship slipped beneath the waves in the Black Pit, it wasn't just the hull that was lost. It was the thousands of tons of cargo inside it. Tanks that would never reach the front, grain that would never make bread, aluminum that would never be shaped into bombers. And crucially, it was the experienced merchant sailors, men who were just as difficult to replace as the ships themselves. The loss of a single fully loaded freighter represented an enormous waste of Allied industrial effort and time. The resources expended to build the ship, the time taken to load it, the fuel burned across half an ocean, all of it erased in minutes by a single torpedo. Donitz's ledger in 1942 showed a terrifying return on investment for the German war machine. The cost of building, crewing, and deploying a U-boat was small compared to the massive strategic damage that a single submarine could inflict on the Allied supply chain before it was eventually sunk. The German High Command could look at the tonnage charts, look at the rate of Allied shipbuilding, and see a clear path to victory. If the attrition rate held, if the curve continued its current trajectory, the British economy would be paralyzed. The American military buildup in Europe would be stalled indefinitely, and the Soviet Union might be cut off from vital Lend-Lease aid. The math was working. The U-boats were doing exactly what they were designed to do. They were making Allied ships disappear faster than they could be replaced. By the winter of 1942, the Allied strategic position was not merely difficult, it was hanging by a thread, threatened not by a decisive battlefield defeat, but by a slow mathematical strangulation playing out in the freezing waters of the North Atlantic. To break that mathematical strangulation, the visual reality of the conflict had to violently shift from the dark, lethal waters of the North Atlantic to the blinding, deafening daylight of American shipyards. The answer to Donitz's ocean arithmetic was forged under a shower of welding sparks in places like Richmond, California, and Baltimore, Maryland. Traditional shipbuilding was a slow, bespoke craft. Keels were laid, frames were meticulously bent, and thousands of steel plates were joined by teams of highly skilled men driving millions of red-hot rivets. A single freighter could take 8 months to complete. The United States Maritime Commission realized that building ships the old way meant losing the war. They didn't need a masterpiece of naval architecture. They needed a disposable steel box with an engine. They called it the EC-2-S-C1, better known as the Liberty ship. President Roosevelt famously dubbed it a dreadful-looking object. It was slow, capable of just 11 knots. It was completely unglamorous. But it possessed one strategic superpower. It was designed from the ground up for mass production. It wasn't built so much as it was manufactured. Industrialists like Henry Kaiser applied the logic of the Detroit auto assembly line to ocean-going freighters. The revolution lay in two specific techniques: prefabrication and welding. Instead of building a hull from the bottom up on a slipway, entire deckhouses, bow sections, and bulkheads were assembled upside down in massive sheds miles away from the water. These prefabricated blocks, some weighing over 100 tons, were hoisted by giant cranes and dropped into place like interlocking puzzle pieces. Crucially, shipbuilders replaced riveting with welding. A welder could join steel plates much faster than a riveting gang. Welding also shaved roughly 200 tons of excess steel off the weight of each ship, steel that could be instantly repurposed to build more hulls. More importantly, while a master riveter required years of apprenticeship, a welder could be trained in a matter of weeks. The shipyards absorbed legions of untrained workers, including thousands of women, turning them into an industrial army working relentless, round-the-clock shifts. The speed of this system defied German calculations. By 1943, a standard Liberty ship was moving from keel laying to launch in an average of 42 days. At the peak of production, 3 new ships were sliding down the slipways into the water every single day. In one extreme exercise that proved the system's raw potential, the Richmond shipyards assembled the SS Robert E. Peary in just 4 days and 15 hours. This was the terrifying counterstrike to Donitz's strategy. A German U-boat could certainly tear the bottom out of a freighter in a matter of minutes, but setting up that attack required weeks of perilous ocean transit, dodging air patrols, surviving depth charges, and waiting for a firing window. The American shipyard, however, didn't have to hunt for the enemy. It faced no weather delays, no escorts, no evasive maneuvers. It simply repeated a ruthless industrial process, day and night, immune to the tactical friction of the Atlantic. Ultimately, 2,710 Liberty ships would be built, a staggering volume of standardized steel that directly challenged the core of German naval doctrine. Donitz's submarines were still destroying ships, but they were no longer fighting individual vessels. They were fighting an automated, continental-scale extrusion of steel. For every flaming wreck a U-boat commander left in his wake in the Black Pit, another perfectly identical hull was already sliding into the water, ready to load cargo. The U-boat was an assassin, the Liberty ship was a factory output, and in a war of attrition, the factory was beginning to outpace the assassin. But launching holes into the water was only half of the equation. If the U-boats were permitted to operate with the terrifying efficiency they achieved in 1942, no industrial capacity in the world could keep up indefinitely. If the sinkings continued to spiral, the sheer mass of the Liberty ships would only provide more targets, burning through steel, fuel, and human lives without delivering the cargo. The Allied strategy required winning 2 races simultaneously, outbuilding the enemy at home and ruthlessly suppressing their kill rate at sea. The shipbuilding miracle had to be shielded by a tactical revolution on the ocean. To survive, a U-boat commander relied on 2 primary elements: invisibility and time. He needed the vast, unmonitored expanses of the ocean to surface, run on his diesel engines to recharge his batteries, and maneuver into position ahead of a slow-moving convoy. The Allied Anti-Submarine Warfare System, or ASW, was not a single magical weapon designed to instantly destroy a submarine. It was an integrated network of technologies and tactics designed to strip away the U-boat's invisibility and deny it time. The foundation of this defense was the convoy system itself. Grouping 40 or 50 merchant ships together, surrounded by a ring of specialized escort vessels, didn't make the targets harder to sink, it made them harder to find. A solitary freighter was a needle in a haystack, easily picked off. A convoy was a concentrated target, but it forced the U-boats to converge on a heavily defended point. Escort commanders were no longer reacting blindly. They were aggressively managing the battlefield around their vulnerable charges. The pressure on the U-boat began long before it ever saw a merchant ship. The Allied intelligence apparatus, spearheaded by the codebreakers at Bletchley Park, was increasingly penetrating the encrypted Enigma radio traffic that Karl Donitz used to orchestrate his wolf packs. While the intelligence flow was never perfectly consistent, It frequently allowed Allied planners to reroute entire convoys around the heaviest concentrations of submarines. When the U-boats were waiting in the path of a convoy, the ocean would suddenly be empty. A U-boat that cannot find a target is a U-boat that is failing in its primary mission, wasting fuel and patrol time while the shipyards in Baltimore continue to launch replacements. Even when the wolf packs did make contact, the tactical environment had become radically more hostile. Escort vessels, destroyers, frigates, and the highly maneuverable corvettes were now bristling with advanced sensor technology. High-frequency direction finding, known as HFDUF, allowed escorts to instantly pinpoint the location of a U-boat the moment it transmitted a radio signal to coordinate an attack. The darkness, which had previously been the U-boat's greatest ally, was stripped away by advanced Type 271 centimetric radar. A surfaced submarine, running fast on its diesels in the dead of night, could now be detected by an escort miles away. This technological web forced the U-boats to adapt defensively. They had to spend more time submerged, relying on their slow, battery-powered electric motors. A submerged U-boat is drastically slower than a surfaced one, severely limiting its ability to maneuver ahead of a moving convoy. The very act of avoiding detection reduced the U-boat's lethality, and the escorts were no longer just defensive screens. The Allies introduced support groups, independent flotillas of heavily armed destroyers that were not tied to the slow pace of a specific convoy. When a wolf pack attacked, a support group could detach, aggressively hunt down the submarines, and relentlessly depth charge them, pinning them down for hours or even days. The most profound shift in this tactical equation came from the air. Throughout 1942, Donitz had exploited the Black Pit, the mid-Atlantic gap where land-based Allied aircraft lacked the range to patrol. In early 1943, that sanctuary began to close. Very long-range B-24 Liberator bombers, equipped with their own centimetric radar and Lee light searchlights, began sweeping the previously safe zones. A U-boat surfacing at night to charge its batteries might suddenly find itself bathed in millions of candle power of stark white light, with depth charges raining down seconds later. Furthermore, the deployment of small, nimble escort carriers, merchant hulls converted to carry a handful of aircraft, brought air cover directly to the convoys. A U-boat commander could no longer rely on the vastness of the mid-Atlantic for protection. The threat of an aerial attack forced submarines to dive repeatedly, further draining their batteries and exhausting their crews. The hunter was increasingly becoming the hunted. Each of these elements, the convoys, the intelligence, the HFDUF, the radar, the support groups, the aircraft, was a strand in a tightening net. None of them won the Battle of the Atlantic alone, but together they radically altered the cost of an attack. A U-boat must find the convoy, evade the radar, slip past the escorts, achieve a firing solution, launch a limited number of torpedoes, and then survive the inevitable violent counterattack. The process took immense skill, nerves of steel, and, crucially, time. By the spring of 1943, this tactical friction was colliding violently with the industrial reality of the Liberty ships. The German High Command could look at the tonnage figures from earlier in the war and calculate that the attrition strategy was mathematically sound. But as the Allied ASW net tightened, the U-boats were simply not getting the opportunities to sink ships at the required rate. They were spending more time hiding, more time diving from aircraft, and more time engaged in desperate fights for survival against aggressive escorts. This is the replacement asymmetry that ultimately broke the German strategy. The sinking of a single Allied freighter was a violent, momentary event that required days or weeks of perilous patrol by a highly trained submarine crew. The replacement of that freighter was an industrial constant, repeating day and night in the safety of American shipyards. The U-boat commander had to risk his boat and his life for every individual victory. The American shipyard worker simply clocked in for another shift. In this brutal war of replacement, the crude, standardized design of the Liberty ship proved to be a devastating strategic weapon. Elegance and individual excellence meant nothing. Throughput, Interchangeable parts and predictable output meant everything. A Liberty ship might be slow and visually unappealing, but it performed its primary function, delivering cargo, just as well as a bespoke freighter. And when a U-boat managed to slip the net and sink one, the strategic impact on the Allied transport network was minimal. The German Navy paid for that sinking with a valuable torpedo, precious patrol time, and immense risk to a highly specialized crew. The Allies paid with a replaceable steel hull, instantly replaced by another identical hull sliding down a slipway thousands of miles away. The human cost of this equation remained horrific. The replacement strategy did not protect the merchant seamen. When a Liberty ship went down in the freezing Atlantic, the loss of life, the loss of valuable cargo, tanks, fuel, ammunition, was real and deeply felt. The U-boats continued to kill people and destroy material, forcing the Allies to expend massive resources on escorts, aircraft, and continuous shipbuilding. The campaign remained incredibly dangerous, but the central strategic question was no longer whether the U-boats could inflict pain. The question was whether they could inflict pain fast enough to shrink the overall Allied logistical capacity before the shipyards absorbed the losses. By May of 1943, the answer was decisively no. The convoys were still arriving. The shipyards were launching new hulls at a staggering pace, and the U-boat losses were becoming unsustainable. For Germany, the cost curve had become inverted. The Allies could lose a merchant hull and immediately build another. Germany was losing complex, highly engineered submarines and their irreplaceable, experienced crews, while simultaneously facing an increasingly dense and lethal anti-submarine environment. The exchange rate had become completely unacceptable. Karl Donitz was forced to temporarily withdraw his boats from the North Atlantic, not because his torpedoes had stopped working, but because the mathematical reality of the war had turned entirely against him. The ocean was still a battlefield, but the economic war had been decided in the shipyards. That economic victory was rooted in a harsh physical reality. The true asymmetry of the tonnage war revealed itself not just in the volume of ships launched, but in the massive disparity of effort required to sink them. A standard Type 7C U-boat slipped out of the concrete pins at Lorient, carrying exactly 14 torpedoes. That was its absolute, inflexible limit. Even under textbook conditions, a commander could not destroy more than 14 targets, but the North Atlantic in 1943 was unforgiving. Rushed firing solutions, erratic torpedo mechanisms, and the constant, violent interference of Allied escorts meant it often required 3 or 4 torpedoes to guarantee a single kill. To secure that one sinking, a U-boat crew had to endure up to 2 months at sea. They navigated punishing storms, survived depth charge barrages that cracked their pressure hulls, and burned thousands of gallons of diesel fuel just to reach the shipping lanes. Once their torpedo tubes were finally empty, the submarine faced a perilous 2-week transit back to the French coast, followed by weeks in dry dock for mandatory refitting. The entire cycle of destruction for one German boat was agonizingly slow and incredibly expensive in both resources and human strain. Meanwhile, the American shipyard operated in a completely different reality. The welders and crane operators in California or Maryland did not hunt for targets, and they did not face enemy fire. They simply executed a synchronized industrial loop. While a U-boat was spending 3 terrifying weeks just attempting to bypass a destroyer screen to get a clear shot at a single freighter, a Kaiser assembly line had already laid a new keel, welded the bulkheads, dropped the prefabricated deckhouse into place, and launched a fully functioning vessel. This massive disparity in effort turned the Liberty ship into a highly unconventional strategic weapon. It was slow, crude, and undeniably vulnerable. Yet its true value lay entirely in its throughput and predictability. In a war of mechanical attrition, elegance loses to volume. When a U-boat managed to slip a torpedo into the side of a Liberty hull, the German Navy paid a premium price: expended ammunition, lost patrol time, and the ever-increasing risk that the submarine would be sunk by a circling B-24 Liberator. The Allies, however, paid with a standardized steel box that the system was already replacing. Before the burning oil from a torpedoed freighter had even cleared the surface of the ocean, the industrial machine had already balanced the ledger. The Allied transport network endured not because it was heavily armored or impossible to hit, but because it had been fundamentally engineered to absorb catastrophic damage at a pace that the German war machine simply could not replicate. By May of 1943, that fundamental engineering advantage converged with the tightening tactical net at sea to create a catastrophic tipping point for the German submarine command. Karl Donitz, the architect of the tonnage war, was finally forced to look at his ledger and accept that the arithmetic had irreversibly flipped. It was a month characterized by a staggering, double-sided defeat. The first blow landed heavily on the strategic equation. The sprawling, seemingly chaotic network of Allied shipyards, churning out the crude Liberty ships, along with tankers and specialized freighters, hit an astonishing milestone. The industrial machine was now launching replacement hulls at a rate of roughly 1 million tons per month. This figure fundamentally obliterated the German math. Even in the darkest days of 1942, during the height of Operation Drumbeat, the U-boats had never sustained a kill rate approaching 1 million tons every 30 days. The Allied shipbuilding capacity had not simply caught up to the destruction, it had radically outpaced it. The overall pool of merchant shipping, the vital arteries supplying Britain, North Africa, and the Soviet Union, was no longer shrinking. It was rapidly expanding, despite the ongoing violence in the Atlantic. The second blow was tactical, and it was devastating to the U-boat fleet itself. As the convoys pushed through the ocean, protected by the increasingly aggressive combination of escort carriers, long-range aircraft, and Huff-Duff-equipped destroyers, the cost of sinking a ship became prohibitively high. The hunters were systematically being hunted down. In that single month of May 1943, 41 German U-boats were destroyed. It was a staggering loss rate, representing nearly a quarter of all operational boats at sea during that period. This was the brutal, asymmetric reality of the replacement war made manifest. When the Allies lost a Liberty ship, they lost a standardized hull carrying cargo. It was a painful loss, but the shipyards immediately replaced the steel, and the broader logistics network absorbed the shock. When Germany lost a Type 7C submarine, it lost a complex, expensive machine of war. More importantly, it lost 50 highly trained, experienced submariners, men who possessed the technical knowledge and tactical instincts required to survive in the North Atlantic. A shipyard could stamp out a new hull in weeks. The German Navy could not instantly manufacture a veteran submarine crew. Faced with this totally unacceptable exchange rate, Donitz made a decision that effectively ended the decisive phase of the Battle of the Atlantic. On May 24, 1943, he ordered his U-boats to temporarily withdraw from the critical North Atlantic convoy routes. He did not issue this order because his weapons had suddenly failed, or because the Allied ships had become immune to torpedoes. The U-boats were still fully capable of sinking targets. He withdrew them because the core strategy of the tonnage war had collapsed. The strategy demanded that every single torpedo fired reduce the Allied merchant fleet faster than the shipyards could restore it. That was no longer happening. The ocean remained a profoundly dangerous place, and ships would continue to burn and sink, but the fleet behind them was growing. Germany could still sink ships, but it could no longer sink them faster than America could build replacements. When Karl Donitz looked back at his ledgers in the wake of May 1943, the columns that had once promised a swift, crushing victory for the Third Reich had transformed into a clear record of strategic failure. The mathematical strategy of the tonnage war had not failed because the U-boats were incapable of killing. It failed because they were utterly incapable of maintaining a deficit against the staggering scale of American industrial output. Over a relentless 24-month period, American shipyards alone poured approximately 24 million tons of new merchant shipping into the water, driven by the mass assembly of 2,710 standardized Liberty ships. This colossal industrial output created an impenetrable wall of steel that swallowed up German tactical successes. U-boat commanders could still achieve isolated, deadly victories in the pitch-black hours of the night, but they were hopelessly losing the monthly arithmetic of the Atlantic. Donitz's entire philosophy required a sustained, compounding deficit in Allied transport capacity. He needed to shrink the pool of available hulls until the global supply chain seized up, forcing Britain to starve and halting the Allied buildup in Europe. Instead, even as torpedoes tore through individual freighters, the total carrying capacity of the Allied merchant fleet was actively growing. The strategic equation had been completely inverted. The Germans had designed an underwater weapon engineered to make ships vanish into the deep. But the United States had responded not merely with warships, but with a continental-scale production system engineered to make that disappearance temporary at the fleet level. Every time a submarine crew risked their lives to send a freighter to the bottom, a replacement was already sliding down a slipway thousands of miles away. Germany could still sink individual ships. It could still inflict horrific losses in human life and valuable cargo. But it could never sink them faster than American industry could build replacements. The tonnage war was over. Not because the ocean had become safe, but because the math had become impossible. The U-boat campaign was fundamentally a weapon of erasure, designed to systematically remove steel from the ocean until the Allied supply lines collapsed under their own weight. But the American response was not simply a counterweapon. It was a continental-scale system engineered to guarantee that every disappearance was mathematically irrelevant. The Atlantic remained a graveyard, but it was a graveyard overshadowed by an assembly line that refused to stop.